This is a video from section 12.3 in a Calculus 3 class. The directions say to determine whether the given vectors are parallel, orthogonal, or neither. Let's take a look at 23a. Suppose a is the vector 9, 3, and b is the vector negative 2, 6. If I take the dot product of a and b and get 0, we will have shown that a and b are orthogonal to each other. And so let's take a look. I'm going to take the dot product of a and b. So that's the vector 9, 3 dotted with the vector negative 2, 6 right here. And so this is 9 times negative 2 plus 3 times 6, which is negative 18 plus 18, which is equal to 0. And that shows a and b are orthogonal. That's 23a. 23b. Suppose a is the vector 4, 5, negative 2, and b is the vector 3, negative 1, 5. Let's take a look at the dot product of a and b. So just like before, if I get 0, then a and b are orthogonal. If I don't get 0, then a and b are not orthogonal. All right? So let's take the dot product of a and b. So that's the vector 4, 5, negative 2 dotted with the vector 3, negative 1, 5. So that's 4 times 3 plus 5 times negative 1 plus negative 2 times 5, which is 12 minus 5 minus 10, and that's not 0. And so therefore, a and b are not orthogonal to each other. So if they're not orthogonal, we need to check to see if they are parallel. So what I'm going to do is set the vector a equal to k times the vector b and solve for k. K is a scalar. So I get the vector 4, 5, negative 2 equal to k times the vector 3, negative 1, 5 right here. And so, therefore, the vector 4, 5, negative 2 is equal to the vector 3k, negative k, 5k. And so now what we get to do is equate the components. So two vectors are equal if their corresponding components are also the same. And so what that tells me is that 3k must equal 4, negative k must equal 5, and 5k must equal negative 2. Now, if we end up solving each of these three equations for k, notice how all the values of k are different. These equations produce different values for k, right? And so what that tells me is that a and b are not parallel to each other, and that's because I can't write the vector a as a scalar multiple of the vector b. And so if they're not parallel and they're not orthogonal, then the answer will be neither. 23c. Suppose a is the vector negative 8, 12, 4, and b is the vector 6, negative 9, negative 3. Are a and b orthogonal? Well, let's take the dot product of a and b. And so that's the vector negative 8, 12, 4 dotted with the vector 6, negative 9, negative 3. And so that's negative 8 times 6 plus 12 times negative 9 plus 4 times negative 3. And that's not equal to 0, and so a and b are not orthogonal. Are a and b parallel? Set a equal to the vector a equal to k times the vector b. And so that says the vector negative 8, 12, 4 is equal to k times the vector 6, negative 9, negative 3. And so the vector negative 8, 12, 4 is equal to the vector 6k, negative 9k, negative 3k. So notice how I have my three equations. I set 6k equal to negative 8, negative 9k equal to 12, and 4 equal to negative 3k. And when I solve for k in each of these three equations, I get k equal to negative 4/3. And so what that tells me is that the vector A is negative 4/3 times the vector B. So in other words, I can write the vector A as a scalar multiple of the vector B. And so that tells me A and B must be parallel. 23D. Suppose A is the vector 3, negative 1, 3, and B is the vector 5, 9, negative 2. So I'm going to check to see if A and B are orthogonal first. So when I take the dot product of A and B, I get the vector 3, negative 1, 3 dotted with the vector 5, 9, negative 2. And so that's 3 times 5 plus negative 1 times 9 plus 3 times negative 2. And when I perform my calculation, I end up with 0. And so that tells me A and B must be orthogonal. And that's going to do it for this video. This is a video on section 12.3, problem number 23. Thank you.